So now we are going to see how transistor acts as amplifier in active mode. Now we can see that there are various modes. These two are the switch mode. These two are switch mode, active switch, and this is the active mode in which it acts as amplifier. So in the case of amplifier, emitter based junction must be forward biased and collector based junction must be reverse biased. Let us suppose we have a PNP transistor and it is connected like this. The base has been grounded. This is PNP transition. I have shown holes with H and electrons with E minus, and here I have shown only the majority charge carriers in the respective region. Now, because I have to make emitter based junction as forward biased, so P side must be at more potential than N side. So here I should place some blank. So I should place some voltage here. Let the voltage be like this. Now is it forward bias or not? See, if you see this is a 0 volt because base is grounded. So base is grounded. So P side must be at more potential. Let us suppose take this example as 3 volt. Imagine this is 3 volt. That means this is at 3 volt. So is the emitter J based junction emitter base in forward bias? Yes, it is in forward bias because P side is at more potential than N side. Similarly, collector based junction must be at reverse bias. So we have to put some voltage here. So how to put some voltage so that collector based junction is reverse bias? We can see we have to put something like this. So this is at 0 volt and so this is at 4 volt. Imagine. So this is minus 4 volt. That means what? See, if you see these two emitter, collector and base, we find this is reverse bias because P side out of collector and base, the P side is at lower potential than N side. So here this is reverse biased. So it can work. Now, this voltage that is applied because base is common and this is applied to emitter. So this is called VEE. This is called VEE. This applied voltage is called VCC because base is common. This is collector. Now, actually the mode of operation depends on the potential difference here. The potential difference here would be applied voltage VEE minus potential drop across this junction. That is denoted by this voltage between this side and this side. So VEE minus potential drop across this would be called as VBE, and this potential difference would be called as between base and collector would be called as VBC, okay, or VCB. You can take VCB. So understand the difference between VEE and VBE. VBE is the voltage externally applied and VBE is the potential difference actually between emitter and base, taking into account this applied voltage minus this drop across the junction. Similarly, VCB is the potential drop between the potential difference between base and collector, taking into account this applied voltage VCC minus the potential drop across this junction. Now, since it is forward biased, this becomes thinner. Since this is reverse biased, this becomes thicker. So here resistance is more. So what happens now? There are basically two independent PN junction diodes where the current moves. So since this is forward biased, so what is going to happen is that this hole is going to cross it with the majority charge carriers. The majority charge carrier cross it easily. Once it crosses it, so holes cross in large number through this forward biased emitter base junction. Once it crosses here, it reaches here, it should combine with the electron. But number of electrons is very less. So it cannot combine totally. So what is going to happen? Because the base is thin as well as it is very lightly doped. So most of the holes that reach here would not find something to nullify. So they are left with only one option, that is to cross it. Now why would they cross it? Because in the N part, these holes which have reached in the N part, in the base, that is N type, these holes in the base are a minority charge carrier, and reverse biasing supports minority charge carrier, because here the negative potential, it is pulling these holes. So these holes would find a favorable condition to cross from base to the collector, because there is a attraction. So from P side to N side, from emitter to base, we are finding there is a movement of majority charge carrier. There is movement of majority charge carriers. The same holes which are majority and supported here are now, after entering in the base, they become minority charge carrier, and to pull them again we want a reverse biasing. So now these same holes would cross it in the form of minority charge carrier. So we are going to get that, and because here doping is very small, so very less amount of nullifying takes place here. So out of this current that is coming here, that is equal to IE, only very small fraction, maybe only 5% or even 2% or 1%, like that, becomes IE is equal to IB. Rest 95% crosses here. So almost 95% of this IE entering here comes here, and that becomes, and this current becomes IC, and that is equal to almost 95% of IE. So in that way we are getting that from this resistance, that is very small resistance, current is I, this resistance is very large and current is slightly decreased, but resistance is increased manifold. So this current, the potential difference here is very small, but potential difference here becomes very large, and that is the amplifying action. So in the case of active mode, we see that the emitter base junction offers very less resistance, and collector base junction offers very large resistance. So we are seeing that how it behaves like this, that there is a current coming, call it IE. Here resistance is R, so here potential difference is IE into R, but in IB some current goes, but here almost in collector IC almost 0.95 IE goes. Example, it can be 98%, 0.98 or 0.99, and here this becomes about 10R or 20R. So we can see that IE into R, potential difference here, and 20R into 0.95 IE, potential difference here. So this potential difference is manifold. So this potential difference is magnified here. So that is the action of transistor as amplifier. Let us see more. Thank you.